Right, so let's try this past examination question. So this question comes from the Core Mathematics C2 January 2007 Edexcel paper, and this is question number 1. So let's take a look. So f of x is defined as x cubed plus 3x squared plus 5, and we need to find in part A f double primed x. So before we attempt the problem, let's go through some notation. Okay, so firstly, if you see 1 prime specifically means you're differentiating with respect to x. So in particular, you're differentiating once with respect to x. However, if you see double primed means you're differentiating twice, specifically with respect to x. So 1 primed, just to repeat, means you're differentiating once with respect to x. Double primed means you're integrating, you're differentiating rather, twice with respect to x. So let me copy down the f of x. So f of x, and that is defined as x cubed plus 3x squared plus 5. And all of these terms are of the form ax to the power n. So all of these terms are of the form ax to the power n, where a is a constant, a and n are constants. And if you were to differentiate dy over dx, so the derivative would be found by multiplying by the power to give you na, and by subtracting 1 from the power to give you n minus 1. Now, if you're unaware with basic differentiation, I have created videos explaining the process along with additional examples, and I'll provide links to those videos in the description below. However, let's carry on. So we need f double primed x. So to work out f double primed x, first we work out f prime x. So primed, as I said earlier, we need to differentiate once. So since these terms are of the form ax to the n, so let's follow through with the basic form of differentiation. So when I multiply by the power, the first term in particular will have 3x, subtracting 1 from the power gives us 2. When I differentiate 3x squared, multiply by the power, 2 into 3 is 6, subtracting 1 from the power, 2 minus 1 is 1. When you differentiate any constant, or number or fraction for that matter, but any constant overall, the outcome is 0. So the answer of f primed x is 3x squared plus 6x. But the question in part A is we need to work out f double primed x. So f double prime means we either differentiate fx twice, or we differentiate in f primed x one more time. So if I differentiate f primed x one more time, so again we have terms of the form ax to the n. So let's apply the basic rule. So for the first term, multiply by the power, 2 into 3, 6, subtracting 1 from the power, 2 minus 1 is 1. When I differentiate 6x, we should get 6, so we're just dropping the x. You could follow the same principle of multiplying by the power and subtracting 1 from the power to give us 6x to the power 0, but x to the 0 is 1. So, and the 6 into the 1 gives us 6. So this is the outcome of f double primed x. So that's the outcome of part A, but we're far from finished. We have another one. So we have another part to do. So part B. Part B is to integrate between limits 1 and 2 fx with respect to x. So let me copy that down. So we're integrating with respect to limits 1 and 2, and we're integrating fx with respect to x. Now fx is being defined to us, so let's replace this fx in our integral. So fx is x cubed, so x cubed plus 3x squared plus 5. And this is basic integration. Now, if you're unaware of basic integration, I have created videos on basic integration as well, and I'll give the links to these videos in the description below. And these videos again give you additional examples and talks through the process in a step-by-step manner. However, let me briefly talk to you about the process. So we're integrating terms of the form ax to the power n with respect to x, and the idea is, provided that a and n are constants, so the process is we add 1 to the power to give us ax to the n plus 1, and we're dividing by the result of adding 1 to the power, so we're dividing by n plus 1 in this case. Adding a c, so just for completeness of this result, I've added a c because this result that I've given to you doesn't contain limits, just for completeness. However, let's follow this method through, this process through, to integrate these terms which are of the form ax to the n. So when I integrate x cubed, adding 1 to the power gives us 4, dividing by the result of adding 1, which is 4. When I integrate 3x squared, when I add 1 to the power 2, we get 3, divided by 3 as well. Integration of any constant, so that would be the constant into x. Let's close that square bracket, and let's write these limits on the right hand side of this square bracket. Now, before I replace the limits, so let me cancel these two 3's. And we need to replace the upper limit in first. Upper limit is 2, so we'll get 2 to the 4 all over 4 plus x replaced by 2, so 2 to the power 3 plus 5 into x replaced by 2. This is what we should have when we replace the upper limit by 2. Always minus in the middle. When I replace the lower limit being 1, we're going to have 1 to the power 4 divided by 4 plus x replaced by 1, so 1 cubed plus 5 into x replaced by 1. Now this is where the calculator kicks in, so you can use your calculator, and if you use the calculator you should have an answer. So I'm going to keep it as a fraction, an improper fraction, which is 63 over 4. So that should be the solution to part B. Now again, if you're unaware of basic differentiation and integration, I have created videos on these explaining the process in detail along with brand new examples, and I provide the links to these videos in the description below. However, if you enjoyed this video, be sure to subscribe, and I hope to see you again. Thank you.